Hi, today I'll be walking you through the PROMIS mobile app, specifically the web part of it and how it functions and what is the flow of the app. The PROMIS app is basically a hybrid mobile app. So before jumping into the code, a quick word about what a hybrid mobile app is. Uh, so basically, when I say something is a native mobile application, it means that it has a native shell and that can directly talk to the device APIs. Such applications are usually written in the language that is supported by the platform. So for iOS, it'll be something like Objective-C or Swift. For Android, it'll be Java, and so on and so forth. Then there's another version of apps called as mobile web apps, where the web app is rendered within the context of a mobile browser, but the mobile browser itself is a native application residing on your mobile device. But a hybrid app is something where you have a native container that loads the web code that you have, and then this container can talk to the device APIs if needed. So the difference between these two is that this here the web code is rendered inside a mobile browser, but here you have a native container and you have the ability to talk to device APIs if needed. Both Android and iOS provide such containers called as web views, and you can basically render your entire web code within those web views and serve it to the user as a native app. So on the same principle, the PROMIS app is also built. All the code related to the web views for both Android and iOS are in their respective folders, as you can see in the repository. And the native side also handles the notifications. But other than that, everything else is on the website. So any functionality related issue that you might ever have, or any functionality related changes that you want to do, you'll always go into the web. You won't deal with Android and iOS. So the first thing that you'll probably need to do is to clone the folder. Once you clone it, this is the structure of the app that you see. Again, we'll not talk about Android and iOS. Inside web, when you go, you'll see a bunch of folders called app and dist, and then there are a few files. Um, the dist folder is something that you'll never touch. It is automatically generated, uh, and it is the final build that is supposed to be deployed in both of these as well as on the mobile website. So this is something that is directly given to the user as the final build. App is where you do the development. So you never make any changes here. You make changes here and then you generate this. And this generation is an automatic process that will be done by Gulp. So first I'll talk about this file package.json. So package.json is something that npm needs to get all of your dependencies. So the only prerequisite to set up this project from a web perspective is you need npm on your system. Once you have npm on your system, you can use this package.json to install any and every dependency that we need for this application. The next file is the gulp file.js. So gulp is basically a task manager. It'll take care of tasks like linting, uglification, minification, strip debug, where it just removes all the console.log messages from your JavaScript files and other such tasks. So you'll never have the need to actually modify this file, but you need to understand what's happening here. And there are many such tasks like linting, minification, and there'll be some copying tasks here. But the two main tasks that you need to worry about is clean and the last task, that is build. So what clean does is so in the distribution folder right now you see a whole lot of code, but what the clean task will do is it'll delete all of this and it'll just make this folder empty. What the build task does is it'll generate a new build for you. So whenever you make any changes in the app folder, you first clean the distribution and then you just do a gulp build. So it'll just generate a new fresh build that comes in here. The next file that I'll talk about is bow file. So the traditional way to get dependencies for your web app is to go to the website and download the library files. For example, if you need AngularJS, you'll go to the AngularJS website, get their JavaScript file and put it in your application. But Bower is a dependency manager, so you go ahead and tell Bower that okay, I need Angular, I need Bootstrap, I need Font Awesome, and it'll automatically get all of these and it'll put it in your application. So you don't have to individually go to these websites and get all of these files. In the Bower RC file, we tell where we want Bower to install all of these dependencies. So we'll create a new folder inside app called Bower components and we'll put everything there. So to begin with, we should first ensure that we are at the web directory where we have direct access to package.json and gulffile.json and bower.json. So first thing to set up is you have to do npm install. npm install will read the package.json and it'll create a new folder called node modules. So node modules will have all the dependencies that you declared in the package.json. You'll get a bunch of deprecated warnings and other warnings, but you can ignore all of those as long as everything installs successfully. So we'll wait for this to end and see how everything goes. So yeah, we didn't have any errors here. So it looks like everything installed successfully. So the next thing that you need to do is Bower install. Now, when you do something like this, the system looks for Bower on a global level. So that basically means that you should have done something like this to install Bower. The -g flag tells it to install globally. But since you have installed it locally and you can go and confirm it, so inside your node modules you have Bower. So if you have a local installation and this is not working, you can simply do something like node modules, sorry, yeah, node modules, and then Bower bin Bower, and now you can do install. So instead of pointing to a global scope, you're just pointing to a local installation within your node modules folder. So when you do a Bower install, it goes and creates this folder. I'll actually delete this. Looks like it was hanging there from before, and we'll go and run this command again. So yeah, now you can see that it fetched all of this for you and it ended successfully, and you have the Bower components folder again here, and you have all of these things in there. So Bower did your dependency installations. So at this point you're all set and you should actually be able to test the application if you want. So go inside the app folder and spin up your web server. I'll be using Python here, but you can use any web server that you have. So when I go to localhost 9000 now, the app is up and running. So that is all you need to basically set up the app and get it running. I'll now walk through the code that we have. So like I said, you'll never touch the distribution folder. You'll always do development in your app folder. Now again, I'll start with some files that you probably have to not worry about a lot. The config.json file basically just uses the release version. It is sort of a config.xml file that you might have in a Java web app or something like that. So this you only update this whenever you're pushing out a new release. There's nothing else to do in this file. The Angular iOS 9 UI WebView patch is again something that you'll never have to touch. It is just a patch that fixes issues with Angular and iOS 9 WebView. So these are the two files that you probably never will have to touch. The images holds the images that we're using in the app. It's a loader and the beer. There's nothing else. The CSS file has some styles that we're using. Nothing very difficult to understand. It's a simple CSS. The JSON folder has mockup JSONs of what each of the APIs from the server side would return to us. It is just a mockup in case you want to test your application locally without ever having to hit the server. Initially, there was a requirement that if the user is not connected to the internet, they can still go ahead and take the survey and submit it. And this JSON folder was created with that purpose, so that we have a mock of questions that the user can go ahead and answer through the app. But the challenge was that we needed to track the survey ID, and the survey ID will never be fixed. It is generated from the server side, and that is why we are now not using this in the actual application. It is just there for development purposes. Okay, now the next thing that you need to see is the partials, the scripts, and the index.html. So this app is built using AngularJS. So I'll not be talking about the basics of Angular, but I'll go through how this app utilizes Angular. Even before jumping into that, you need to have an eye for these functions, because these functions are what the native wrapper will call. So if the native side of the app needs to get some information from the website, it'll call these functions. So these functions, if you want to add any new function, you have to add it here, and the native side will access them using these names. That is the entire purpose of these functions, nothing else. So now talking about the Angular side, so the app uses these partial views, and those views are substituted here inside your ngView div. So based on whatever route you have, the views will be getting substituted here. This is basically an MVC pattern where your route decides which view, which controller, and which model should come into picture. This is all that is there in the index.html. There's no actual view residing here. The next thing you need to see is the app.js file. So the app.js file has a bunch of configurations for the app. So the first configuration is the route provider. So the route provider talks about the routes that the app has. So the default route is just a slash, which loads home.html from your partials folder and its corresponding controller from the controllers folder. The slash survey route loads the survey.html and the survey controller. So based on the route name, each partial is named accordingly, and the name is also coherent with the controller name. So if it is home.html, it's a home controller. If it's survey.html, it's survey and controller. So it's very easy for you to understand which controller is associated with which partial view. The next configuration that we have is the HTTP provider here. So this is used for basically two purposes. The first purpose is enable cross-domain service calls. This is something that Angular does not support by default, and in certain cases it also makes some errors when you're trying to do some cross-domain calls. So it is essential to set these here, and the code here that you see is basically for your error handling. So this is an interceptor that intercepts every HTTP request that is sent to any server side. It'll check for a bunch of things, and it'll show it'll actually set errors based on whatever is the scenario. So if the user is not online, you set the error as offline. If there's a server error, then you set this. So this is basically an interceptor that intercepts every HTTP request. And then finally you have this configuration that basically says that the user should not be able to go on any other route unless they have if they've completed the survey, they shouldn't be able to go on any other route. So by that I mean that if they have completed a survey, they cannot land on these two. In fact, yeah, they cannot land on these two routes. The only way to go to these two routes is from the home view. So from home view, you click a button to start a survey, you go to the survey, and then you jump to the survey end. So you cannot directly go ahead and change the URLs to land on these two routes. This is basically to ensure that there's no one tries to enter them directly and mess around with the data, and that is the reason why this code is there. Again, this file is something that you'll never have to probably edit unless you're creating new routes and new views. Okay, now what I'll do is before jumping into partials and their respective controllers, I'll talk something about factory that basically does two things. It makes all the service calls that the app needs, and it does data management across controllers. So first I'll go to the service call.js. So this basically is a service provider that will make all the HTTP service calls for you. It'll also make up the parameters that are required for post calls, or it'll ensure that all of the method names are correct, all of the domains are correct. So again, you won't have to touch anything. This is something that you just should come in and understand, look at it. But there's nothing that you'll ever have to change in this. This is basically already there for you. When you need to make a service call, you just use this factory method and make a call, and it'll return the success and error throwbacks to you. So sorry, success and error callbacks to you. You can use those callbacks and handle everything that you want to do inside the controllers, so you don't ever have to come here. The active data.js is there because Angular doesn't provide a direct mechanism for controllers to communicate. So if any of these controllers need to pass some data across, each one of them, they cannot do that directly. There are two major ways that the industry uses. The first one is to pass the data through something called as root scope, but that is usually not considered a good practice. So the other way around is to create a service provider like we have done here, Active Data. This is basically a singleton, so you cannot create instances of this. You can modify this design pattern to return instances, but right now the way it's implemented is it's a singleton right now. And this is basically a getter setter class. That's all that is. So you can call a getter from one controller, and the other controller can call a setter or something like that, and that is how the data is exchanged across controllers. Again, this file is something that you'll never have to edit unless you're adding some new information that has to be communicated across controllers. Um, Next, I'll talk about the error controller and the error HTML partial view. This is there because we wanted to have a central mechanism for error handling. So most of the views and controllers have their own internal error handling mechanism, but in case we come across an error that we never anticipated, this error handling logic will ensure that the user is taken to this page, and when they are on this page they can take a screenshot of it and they can send it across to us, and we can have a look and understand what was going wrong. So the error controller is basically it'll get the question number, the survey ID, the questions, and it'll show all of this on the page, and the user can, along with the error message, the user can take a screenshot of this and then send it to us so that we can go back and have a look to see what went wrong. Again, this is something that you'll never have to edit because it is already coded for you. And this page, this partial view will only come up when there's some error that we are not anticipating. The next file that I'll discuss is the home.html. This is where the code begins. So here you can see welcome, and then there's a survey message, and we tell the user to configure their pin and server settings using the settings button. So there'll be two buttons on the screen. One will be to start the survey and one will be for settings. That is all that is there in this page. Now the associated controller is the home controller. One thing about most of the controllers that you'll see across the code is that there are certain repeating patterns that you'll see. So so again, this is not object-oriented programming, so you don't have any constructors here, but you can actually simulate the behavior of a constructor by creating a method and then calling it at the end of the controller. So basically what will happen is when the controller loads, it will go through all of this code and it will automatically call this method, so it behaves like a constructor. So in all of the controllers that you have, you'll have this controller init method that is basically a constructor that basically acts like a constructor. And then you have this change page method that will be used to change the route. So this is something that you'll find in almost all of the controllers, and it's consistent, and it's you don't have to worry about what it's doing. The change pane just changes the location, and that's all there is to it. Now coming back to the home controller, so in this constructor for home controller, we check if the survey was completed. If not, we just set it as false, that the survey is not completed. We go ahead and check in the local storage if there's a survey in progress. If not, we set it to -1. We check for pin. If there's no pin setup, we tell the user that you don't have pin and server setters set up, so they have to go into the settings menu and set it up. If we actually check for both of them, so if the server is set up correctly but they did not set the pin, we show just this message, otherwise both of them. And then these are just the checks. If there's already a pin set up, and then we set it to the local storage, and we generate it for the payload. So this payload is for this API. The check surveys API basically tells you if a user with specific pin has any surveys due. So again, like I said, you don't have to write any HTTP calls here because we already have this service call factory method. So all you do is you make a new service call, tell it which service you want to call and what is the method. That is it. Um, like I told you initially, we had the requirement that if the user is not connected to the internet, we can go ahead and read it from a local file. But this chunk of code is not used right now. We always call the remote data source. So when you do a remote data source, you created an instance of the survey call here, and you just do a dot call here. You send the payload, and you tell it what are your callbacks. So you have two callbacks. One is for success, and second one is for error. Uh, so in the success callback, what happens is it comes back and tells you that, okay, the user has some surveys to take. We pick up which is the most recent survey. We set it up in active data, which is used, like I told you, it is used to communicate across controllers. And then, we use this flag, okay to start. If it is okay to start, we disable the button. And that is how the user can enter into the survey. If this is not, if it is not enabled, the user can never actually start a survey. So even though we have response from the server, unless and until we know it is okay to start, we don't let the user start the survey. And then based on whatever the status is of the survey, we tell the user that, okay, you have a new survey due, and to begin the survey, click on the button, or you already have a survey in progress. We check the progress by this local storage key called survey in progress. When the user starts a survey, we basically set the survey instance ID in this local key. So we'll get to that when we see the get survey method. And so this is basically, it just checks whether a user has a survey due. It enables the button so that the user can take a survey, and it just shows the appropriate message for the user. The service error is a generic error handler. Any service calls that we make in this controller, the error callback is the same. We check what kind of error it is, and according to that we show the message so that it is easier for us to find out what the actual error was. The get survey makes a call to the get survey API, and we get this survey instance ID from this survey ID call that we made, and we basically send that survey instance ID to this service, and when it comes back we get the instance ID. So it comes back into this method, get survey success. All we do is we take the survey name, we take the questions, we take the ID, survey ID, and we set it to active data and local storage as and when required. And once this is done, we automatically change the location so that the user can start survey. Now this method is called when the user clicks on the start survey button. So it is important again to know that the first thing that happens on this page load is we check whether they have a survey due or not. If it is due, we make this button enabled, and then the user clicks on this button which calls this method, and we get the survey questions and other survey related data, and then we let the user start the survey. Now the survey is entirely inside survey.html. Its corresponding controller is survey controller. So right now there are only two kinds of questions that we have. One is this SVG question, that is the body paint question, and the other one is radio button question. So this is where the radio button question is. There's already some code that is there for the checkbox, but it is not really used for the application because it's now just a single single choice correct kind of question. So this is how the radio button questions are loaded, and this is where the SVG gets rendered. So we did not hard code this SVG. We used a tool called Inkscape where you can actually draw the SVG and it gives you out the entire SVG code for you. And then we attached handlers to it so that we can know which body part was clicked and what was the value of the pain intensity and stuff like that. And finally, there are two buttons at the bottom, previous and next. All these buttons do is increment the counter of the question array. So we don't go to a new view, or we don't change views. All we do is increment the value of the question array, and that gets changed here. So AngularJS, as you might already know, has two-way data binding. So if the data is changed in the model, the view automatically updates it. And then at the bottom we have a progress bar to show the user how much progress they've made. The controller, again, the survey controller is pretty simple. The new things here are probably the watchers, but other than that, you'll see some things similar to the home controller. So yeah, so like I said, change page method is similar to the home controller that we saw already. And then for go previous and go next, I told you that all we do is we change the counters. That is it. If the counter reaches the end, we change the page to survey end. That is all that we do. There's no actual playing around with questions here, because we have the questions in a global array that we get from the active data. All that happens in the controller init. We get it from active data, and we see what questions are and what is the survey ID, what is the survey title. We also back up all of the information. So for example, if you're able to hit the server and you're able to get the questions, the survey ID, the survey name, but after that the user goes out of the app and somehow loses connectivity, we still have the questions in the local storage. So um, that ways we ensure that even though the user does not have connectivity, and we already have the actual questions related to the survey, so we can show that to the user instead of telling them that they are not connected to the internet. The next, again, most of the code in this is related to the SVG, where you click and how it is updated. You can have a look at it. We basically track it with certain scope variables called as no pain check, pain intensity value, part click, last selected part. It's something that I'll not walk through. It's something pretty simple to understand. But what's important here is to understand the watchers. So watchers will basically watch for certain scope variables and let you know if they changed. So we need to keep a track of these watchers, because we need to save the state of the survey. So if the user answers a question, we need to ensure that that answer goes into the local storage. And also, if the user answers a question, only then they should be able to jump to the next question. So all of that is done in the watcher. So in the watcher, we check if selected answer was changed. If it was changed, what was the value and stuff like that. And then we save the answer to local storage. So the saving is pretty simple. We just take the survey ID and we take the question ID. So we do survey ID colon question ID. That is the key in the local storage, and the value is whatever the answer the user selected. And similarly, before loading a question, we check from local storage whether that question was already answered. If it was already answered, then we go back and select that option for the user, so that they don't have to go in and select that on their own again and again. So if they have 25 questions, they already answered 10 questions, and they somehow get out of the app, come back again, all of those 10 questions would already be answered for them. So that is how we track the state. So all of that is tracked inside the local storage. You don't have to do anything else. So if even in future, if we have more questions that we get, this logic should automatically work for that, because all we are doing is we need the survey ID and the question ID, and as long as that is being returned, we can save answers to local storage or get answers from the local storage. The next one is the survey end, where so if the user reaches to the last question of the survey, they're automatically sent to this. Here they are supposed to enter the pin again. Once they have the pin, we check the pin. If it is the same pin, then we submit it. So that is all that is happening here. We take the pin and we do some pin checking. If it is okay, then we call this method, which basically goes ahead and calls this service endpoint, and it sends all of this payload, and we submit the survey. Uh, again, another important thing here is we don't go back and get all of the answers. As the user is answering each question, we keep a track of that in the local storage, and once they're done with all of the questions, the local storage is populated with something called as the survey ID colon value. So suppose the survey ID is 101, so all of their answers will be in the local storage corresponding to a key called 101, and then we take all of those values here, and then we generate the payload that we need to send. So the payload is like survey ID, timestamp, and the results. So this again, another important thing is that this helps storing these answers in local storage helps the native side to submit these answers as a background service if the user loses connectivity on this page. Then what we have left is the settings controller, which is again a simple view where we have a bunch of settings where they need to enter the pin, the server address, and then there are advanced settings for selecting reminder interval, time to complete, and protocol, and all this stuff. The controller just gets those values and sets them to local storage. There's nothing very difficult to understand in this file. Yeah, I think that is also a quick overview. The app uses these routes to load specific routes. It is the way the naming convention is that whatever is the partial name, that same name has been used to name the controller. So if you know what partial you're looking at, you know what is the associated controller with it based on the name. Each of the we only have like 4 views. Each view has its own specific controller, and the state management is done through local storage. So everything that we want to save as a state is saved in the local storage, and the data amongst controllers is communicated using active data, where we use getters and setters. Again, I'll repeat that this is a singleton. So if you want to have some object-oriented kind of behavior where you instantiate active data and pass around objects of it, then you'll have to probably change this design pattern and use some other JavaScript design pattern to return instances instead of having simple getters and setters. And I think that's about it. So once you're done with coding all of this, you basically just need to ensure that you run gulp clean and gulp build. I'll try running that, but I'm not sure if it will work correctly because I'm on a shared system in the Peralta lab, so I don't know if everything will go ahead properly. So again, you need to ensure that you're in the web folder and you have direct access to the gulp file. So you need to do something like gulp clean. Yeah, it'll tell us that it's not installed. It's the same issue that we faced with Bower. So again, you'll have to do something like node modules gulp bin, and then there should be gulp.js, and you do a clean. So as soon as I do a clean, you can see that the distribution folder is empty now, and I do a build. So it will run all of these tasks. It'll do a linting, minification, and copying all of that, and then it'll generate this distribution folder for you. We're getting some errors here, but you can see that this is not something related directly to our code. So if you get such errors, then you can basically ignore those. But if you get some errors related to your file, those will be shown above this. So we can do a quick test of that. So I'll just go into any of the controllers and I'll try and introduce a linting error so that we can go ahead and see how gulp reports that for us. So if I do this as double equals, which is not checking the type, it just checks values, and I do gulp clean again, so distribution is deleted, and I do a gulp build. So it'll go ahead and build it for us, but It should have shown that lint error. Yeah, I think it is because Gulp is not properly installed. But anyways, so you know that whenever there's an error, it'll basically come up when you're doing a Gulp build task. So that is all. Thank you.